Thank you, everyone, for joining me today on quite an eventful day here in the U.S. As I mentioned, this should be about a half-hour session. May take a little over, but we'll hopefully have some time for questions at the end. Again, thank you for joining our webinar on how to choose a remote field monitoring system. With you today, I am Richard Rodriguez. I joined Onset about a little over a year ago, so back in 2019. I've got experience in working with agricultural researchers and growers, universities and environmental agencies. For those of you not familiar with Onset already, we have been engineering and building data loggers and sensors here in our headquarters in Cape Cod, Massachusetts since 1981. Our products have been deployed all over the world and are well trusted for their time-tested reliability and quality. We do have a global network of distributors, so you can get our products pretty much anywhere in the world. Some housekeeping items. This webinar is being recorded and will be available later in the next few days. You will receive an invitation or a link from our marketing department so that you can access this webinar at a later time. For anyone with any questions or in need of any help, please feel free to enter your questions at the bottom of or the questions section of your control panel. Now we'll get into our webinar. I'll cut my webcam to save the bandwidth, and we'll get right into it. So today we will do a brief introduction into field monitoring systems. I'll discuss different tools that are available for these systems, and we'll get into the benefits of the remote monitoring systems for growers or farmers, agricultural researchers, or any other type of researchers really, and briefly touch on indoor applications. And then we'll get into the bulk of the presentation, which is the factors to consider. All right, so why consider remote monitoring systems? Remote monitoring systems can help you, of course, monitor any area not close to you where you're able to log data immediately. These are great to provide you near real-time environmental data from anywhere in the world for hard-to-reach places. For web-connected systems, these can actually alert you of critical conditions at specific points in the field. They can ensure data is getting collected and devices are running as expected because you can monitor them as they're deployed. You can get a head start on research by viewing data as it's collected. And you can plan for commercial settings, growing perhaps. You can plan your operations and priorities on the farm or greenhouse day to day. For tools that are available, the more common types of devices or sensors that we sell with our remote monitoring systems range from soil moisture to temperature and relative humidity, rainfall, light sensors, wind speed and direction, leaf wetness, barometric pressure, water level, evapotranspiration, and pulse inputs. That pulse input, not actually a measurement, but something that allows you to tie in other products on the farm. Looking at growers specifically or farmers, benefits range from reducing costs associated with irrigation by allowing you to plan your irrigation based on plant demand rather than a set schedule. You can protect crops and cattle from frost and excess heat. You know that frost protection is actually a main driver for our product sales here in the Northeast. Avoid wasting applications by applying pesticides when conditions are not suitable. So you can monitor temperature and humidity to understand when risk of pests may be highest, or when the time for application is not best. These devices can help you ensure that you're meeting regulatory requirements when you apply pesticides. So, for example, you can check wind conditions prior to spraying. Out in California, you can monitor your water usage to ensure that you are not using too much water or have any water losses that you're unaware of. You can also monitor multiple points in wide areas quickly. So with labor becoming scarce at times, it's easier to understand what's going on and cover a large area of farm without having to actually go out to that point. And crop planning. So with temperature measurements and at different points, you can better understand where to plant specific crops based off of their susceptibility to frost damage, for example. You can also plan harvests around the conditions the plants have seen. I did talk about savings from spraying and pesticide applications. An example of these savings, for an example of these savings, we can look at a 2017 survey of farmers conducted by NEWA, or the Network for Environment and Weather Applications, which found that farmers saved an average of $4,300 from reducing sprays, up to $33,000 that was saved from avoided crop losses. On average, farmers saved over $2,000 per acre based on this, and the cost of one of these systems, you're looking at a payback period of under 1 year for someone with an acre of farmland. For research, on the other hand, this type of systems allow you to monitor remote sites that are difficult or even impossible to get to at times. They help you ensure losses of data due to damage of devices, because rather than the data being stored only on the hardware, it's also saved in the cloud. For the sensor network, so when we're talking not just about a single station, but a network of sensors, it becomes a more cost-effective way to monitor multiple points across a wide field, which makes it easier to get higher definition of the conditions you're studying. So these environmental monitoring also extends itself into indoor applications. Our Hobo products actually offer several options for monitoring air quality in hotels and office spaces. We also have popular products for ensuring air quality and the preservation of highly valuable items in places such as libraries and museums. Because of COVID right now, we're actually seeing a large interest in monitoring CO2 in classrooms and offices as a way to verify sufficient air exchange in specific rooms. We've recently introduced a HoboNet indoor product for more demanding applications in terms of distances of communication and environment. This lends itself pretty well to monitoring air temperature and humidity for warehouse applications, for sensitive items such as electronics and apparel. We're also seeing these being used in food storage type applications and restaurant coolers and freezers to protect from food losses due to power or equipment failures. And now finally, we get to the factors to consider. I'll cover 11 different factors to consider when you're selecting a field monitoring system. And to start, we'll look at single point versus a network. So the most common type of stations that are deployed, or data logging stations that are deployed, are single point weather stations. So these stations can collect typical environmental data associated with weather stations, or can be really tailored to collect the measurements that you need. You may want a full weather station with temperature, relative humidity, rainfall, light, wind speed, and direction, or you may want to really focus on temperature or any subset of that, really. Data can be monitored remotely, or it can be stored on site if you are unable to get to the site, and then you would actually have to get out there to offload the data. So there are options requiring you to be on site to offload the data, and options that with a cellular or internet connection, you can get your data remotely. On the other hand, then you have the wireless sensor networks, which basically take the weather station we just covered and add the capability of adding wireless sensors, so that you get, in addition to getting a general sense of the weather or environmental conditions on a research site or a farm, for example, you can then study how, say, temperature changes from point to point within that field by adding wireless temperature nodes or wireless wind speed sensors at different microclimates, so that you can really get a feel for how those microclimates change from point to point. These tend to be web-enabled. In our case, they are always web-enabled and use either a cellular connection or other internet connections, such as Wi-Fi or Ethernet. Which one is right for you? Well, wireless weather stations provide a great way to monitor environmental conditions in a field without much variation in elevation, slope, soil type, and other factors which can cause changes in conditions, such as what you see on the top image. If monitoring conditions in a field with changes in topology, soil types, and other factors, a wireless sensor network can provide more detail into these microclimates, as changes in elevation and slope will create pockets of air that's, for example, the cranberry growers that we work with, their cranberry bogs are set at a lower elevation, and they're actually each set at different elevations. And so understanding what the temperature is at each of those points, it becomes very important in terms of frost protection. In this case, really, the wireless sensor network becomes a more efficient, cost-effective solution, because it allows you to actually see what is happening at each of those points without having to have a specific data logger for each of those points. Now, getting to connectivity, the second factor to consider. We have local offload. So for locations in which internet connectivity is not available, whether it be through cellular connection, LAN, or Wi-Fi, standalone solutions are available. So two examples of these are the Hobo H21s and U30 data loggers, which you basically deploy. You connect 5 to 10 sensors to. These are wire sensors. You can have a complete weather stations plugged into these and deploy them for extended periods of time. They range from being battery powered to giving you the option of having a solar panel for longer deployments. And then after a period of time, you would have to come on site with a laptop and offload your data, or take the device back to your office with you and collect that data. You're really viewing historical data at this point and seeing what occurred in the past. On the other hand, we've got your web-enabled options, such as our RX3000 and RX2100. These are connected to the cloud by either a cellular connection, Ethernet, or Wi-Fi. And these are great because they allow you to monitor conditions remotely and give you a near real-time perspective. We don't currently offer satellite solutions, but some satellite options are available. And again, with these web-enabled options, you not only get your data in real time, but you can also have the capability of alerts and make decisions real time, such as planning irrigation events or harvest. The next factor, ease of deployment. For ease of deployment first, we'll talk about linking each sensor to the station. The simplest of methods is wiring. Direct wiring can be as simple as plugging in a smart sensor, which is then automatically identified by the logger, or it may require some scaling of units, basically telling the data logger what that sensor is and how to translate the information it provides. With our smart sensors, for example, they're all plug and play. So you basically plug them in, they're ready to go. There's no needing for scaling or programming. For wireless sensors, what I find to be the easiest is a push button type setup, much like pairing devices at home with your router or any Bluetooth headset that you have. You basically push a button on the data logging station, put it into search mode. You push a button on the sensor, and they pair themselves up, and you're good to go. Other devices require the use of an app. This isn't our case, but there are other products out on the market that you would use a mobile device app to set them up to the data logging station. This is also a somewhat easy method to do, something that many of us are quite a process that we're quite familiar with. Less common are dip switches. So you would select or position different dip switches to pair devices. This is similar to old garage door openers, for example. And then other more complex devices actually require some type of programming, which makes this a little more cumbersome. For ease of deployment, you may want to find solutions that actually use one of the first two methods. In terms of mounting, typically smaller equals easier to mount. You want to look at whether the devices have integrated mounting provisions. Do they accommodate zip ties or screws, any type of hardware to mount these to material that you have available? On a research field or a farm, you're probably looking at having wood posts or some type of PVC pipes available. These make it easy to mount with either screws or zip ties. You want to look at what kind of power these run on. Do you need batteries? How often would batteries need to be replaced, or is there a solar power option, such as what the Hobo devices for outdoor applications? They tend to all have solar panels built into them, so that the batteries recharge during the day, and you can get extended deployment periods from there on out. And is security a concern? Are they easy to hide? One of the biggest challenges a lot of our customers have is that their devices are actually stolen or vandalized, typically when they're deployed in public spaces. Not so much of an issue when they're on private property. And next, looking at software. How easy is it to, or how easy and intuitive is it to configure and learn how the software operates? Is it easy for you to use? What kind of information does it display? Does it display the most relevant information to you? Can you configure this to make it suitable to your use? Can you share the data with others? We do have we find quite a few customers that like to share data, whether it be with colleagues, other farmers, customers even. They'll share environmental data from their farm, for example, with customers. They you may be interested in automated sending of data to either an email or an FTP site, and then web services. You may have some other type of software you're running and where you just want to integrate data from our devices. And for anyone with large areas to cover or obstructions to a wireless signal, wireless coverage and its adequacy for your application and location is a major factor of concern. So you'll want to look at what type of frequency or what type of wireless connectivity is being used. You want to know what the range is, how many nodes can be included in a network. The number of nodes will determine, how many points you can measure off of a single system. How many hops are enabled, or are you able to get? We'll cover that a little more in detail in the next slide. In terms of the wireless frequency, there are different frequencies that you can go with. Some that give you a longer range, while others give you higher resiliency in getting through walls or foliage. We use a 900 megahertz signal, which is the line of sight range is a little lower, but it can actually get through walls and foliage, which the funny thing about farms and forests is that there tends to be foliage associated with those. So we found that to be a more robust signal. Typically, point of comparison is the line of sight for wireless range. It just gives you a point of comparison from device to device. Typically, you'll be able to find what mounting height that is set at. I think we typically provide you that information for 6 and 10 feet mounting heights. And then in terms of covering a wide field with several measurement points, you want to understand what type of network you can create. So the most simple form is the star network, and basically in a star network, all the sensors must communicate back to the central station, which then sends the data to the internet. This limits the range of your sensors in terms of distance to a radius around that central station, depending on the maximum communication distance between each sensor and that station. On the other hand, with mesh networks, similar to what HoboNet uses, with these mesh networks, sensors can communicate through each other, so they relay the message from one another to that central station. The advantage here is that because you can relay that information from one sensor to the other, you can extend your network of sensors out much farther from that central station. This increases the coverage of a single central station, and this is where then we get into the number of hops that I mentioned in the previous slide. For example, for Hobo, you can do 5 hops before you get to the central station. So meaning you can have 5 devices extending away from each other, away from the central station, given that we have a maximum distance of 1,500 to 2,000 feet from device to device. You can go 1,500 feet from the station to the first sensor, another 1,500 to the next sensor, so on and so forth. And you can do that up to 5 times. In effect, getting up to between 7,500 to 10,000 feet radially away from that central station. This translates to roughly 8 to 10 square miles of sensors operating off a single HoboNet station and a single data plan. And when you're looking at cost, this is where we provide you a great deal of value. In terms of actionable information, you want to understand, does the software provide you any information that allows you to take action? Can you view, can you actually look at any other information outside of just what is being measured, such as battery health or the health of the wireless connection, so that you can take action before you may lose valuable data in research? Do your dashboards show critical information on environmental conditions? So if you're typically on the go, you need to make, perhaps you want to have dashboards that allow you to quickly view what's going on, so you can make decisions on the go. Then does a sensor network integrate with third-party services or any other services, such as crop management networks or software? Perhaps you want to integrate with irrigation monitoring and control systems you already have. HoboNet, for instance, integrates with NEWA, the Network for Environment and Weather Applications, and similarly FAWN, the Florida Automated Weather Network, which provide you great tools for irrigation, crop and pest modeling. They basically take data from your specific location and provide you give you an indication of the risk of the occurrence of any pest or irrigation needs, so that you can take action while also caring for the environment. We've also recently added Aquarius by Aquatics Informatics for anyone doing water projects. This is a pretty popular water data management software. A big feature for a lot of these remote monitoring systems is the ability to get alarm notifications. Again, here in the Northeast, one of the big drivers of need for our products is monitoring critical temperatures, especially early spring and late fall for frost conditions for different types of berries, blueberries, strawberries, and cranberries being the big one. So you want to understand what kind of alarms the equipment triggers. Can you set your own thresholds remotely? Can you have different levels of notifications? And then one point to really focus on is whether these alarms are in-station or they're web-based. The difference here is for in-station alarms, they provide a more immediate response, meaning the sensor takes a reading and it notices that the temperature is too low, for example, and it immediately triggers a call to you or a text message to be sent out, for example. Where web-based alarms, you have to wait for that measurement to get taken, and then depending on the call, how frequently a call is made from the device to the web service, that will then dictate how quickly you get your alarm. So if you have this data getting uploaded every hour, then that call can take up to an hour, that alert can take up to an hour. If you have this data getting transferred every 6 hours, and it can take even longer than that. So we find it for critical situations that these in-station alarms may be preferable. Then when you get an alarm, do you need to turn something on or off? If so, look for a system that has different relay output options. For example, in many situations for cranberry farmers, when they get an alert indicating that a temperature is too low, indicative of frost risk, this alert can also trigger a relay to initiate the irrigation pumps that then start spraying water on the cranberries, thus protecting them from frost. Maintenance of historical data. So this really comes in 2 points here. One, you can use this historical data or access this historical data to make improvements year to year to your operations, but it also serves a way to protect against future claims, whether it be using environmental data to prove that wind conditions were appropriate when you sprayed, to protect against claim that your pesticides may have damaged someone else's property. You can also use rain, wind, and temperature data to support insurance claims for crop losses. So say there was a large rain event, these systems will actually record that data and store it so that you can use that when you're filing your claim. Scalability. So assuming you expect this to be a permanent or long-term deployment, you'll want to understand the possibility of you actually scaling this up and adding sensors to the network. If there is, this is likely that you'll want to add more sensors and capabilities to your operation as you grow, as you learn how to really use these devices. You'll want to select a sensor network, which easily allows you to expand it in the future. Part of this is also understanding the maximum number of sensors and their maximum range, along with the types of sensors that are available. A common request that we get is for the ability to not necessarily add new sensors, but also integrate existing equipment for remote monitoring. An example of this is monitoring pumps to confirm that they are running, check water pressure and water lines. So basically taking sensors that may already be there and just build them into our network. Actually, still on scalability, we want to consider different types of sensors that you can combine. Just before this webinar, an attendee asked about being able to do a hydrology type study, and I believe the need is to monitor different things such as water level, rainfall, soil moisture, for an example. So this is something that manufacturers such as OnSite can do, because we have such a wide array of measurements that we provide. Our sensor networks are built so that they're capable of incorporating all of these. So for an example, our RX3000 station gives you the ability to combine a water level measurement with wired or wireless options for rainfall. You can also incorporate different types of soil moisture sensors, from volumetric water content to soil water potential. We have single point devices and multi-depth soil moisture sensors, and then a water level module, so that you can really do this whole study off of one device and get all this data remotely on our cloud service. Then total cost of ownership, cost to consider. You'll want to look at the initial costs, annual fees, understand if there are any annual costs or recurring costs. So one typical example of this is data costs. So for example, with OnSite, you would purchase the hardware. That hardware is yours. There's no recurring fee for the hardware. The only recurring fees are data. So the more data you use, the higher the plan you would have to get. So the amount of data you need is tied to how many sensors you have in total and how often you're taking a measurement and then uploading that data to the web. While other manufacturers do have recurring fees on the actual devices themselves. So you may pay a fee up front for the sensor and the station, but then there is a recurring fee for that on top of the service that you're using. And then, of course, there is a value the product provides on the other hand. So you'll want to consider the impact or the positive impact that these devices will have on your profit when making the decision. So earlier in the webinar, I mentioned the NEWA study showing that on average, farmers saved just over $2,000 per acre. The station that those customers uploading data to NEWA are using, the base station costs under $1,900. So you're talking about after being paid off after a year, and then it all being a profit after that. And then there's time savings, that being able to do more with and less time. And a big thing is determine if local grants or subsidies are available. These may be general for growers. They may be specific to certain industries or crops. So it's always important to look, check with your local organizations to see if there are any grants available. And then time horizon. So how long do you expect this product to provide value to your activities and decisions? Just to give you a quick example of quick framework of how much these products cost. So a web-enabled station, our lowest cost web-enabled station is our Micro RX, which starts at $560, $620 for the version with a solar panel built in. Say you're just looking to monitor temperature to protect from frost. You're looking at a $95 adder. Your data plan, if you need cellular connectivity, is $150 per year. So for your first year, you're looking at $865 for that solar option, and that gives you a year worth of data. A more complex example, just to give you an idea of how that can grow. So here we have an example of someone doing frost protection monitoring at some cranberry bogs, and they're using our RX 3000 station because they want higher capability. So not only do they want to monitor temperature, but they also want to control the irrigation system with that. So in addition to the wireless sensor, so they're basically they have the station set up near the pump house, and then they have they have the temperature sensor actually in the cranberry bog, so that they're getting that real on location temperature measurement and not having to estimate how many degrees off the temperature would be at the actual bog. In addition to that, they're using the relay module to wire a pump to, and then they have a pulse input sensor that will tie into the water meter. And so this will allow them to get that temperature measurement, get an alert whenever the temperature goes below a certain point. This can activate the relay, which starts the pump, and they can get confirmation that that water is running. All this for under $2,000. Finally, who owns your data? Is the data collected for your use only, or is it used for a third party? I bring this up because there are some models out there, a lot of these new startups, that they actually provide devices at a much lower cost, but then they take your data and they share your data, they sell your data, and they monetize that data. And that's how they basically pay for the devices that they sell you at a much lower cost. This may be okay. In many cases, you may not be okay, or may want to keep these data specific to you. So just something to be aware of, or a quick question to ask. For the record, we do not share data on-site. For on-site customers, data is theirs and theirs only. And with that, I will be open to questions. We're just about 10 minutes over time. So Jessica, do we have any questions? I'll have my great colleague Jessica hop on right now.
Hi, Richard. Thanks. Yes, we did have a couple great questions. The first talks about the RX 2100 stations. So just wondering what station option will be best to monitor water level?
So if you're looking for water level only, and perhaps a handful of wired devices, the RX 2100 is your lowest cost option and will do everything you need to do. If you, on the other hand, need, we just had a customer a couple of days ago looking to have 2 water level loggers on one station, or combine water level monitoring with wireless sensors, then you would have to upgrade to the RX 3000. But the RX 2100 for water level would be a great solution.
Okay.
And that is always something that our water expert Andrew can help you with. Make sure that you get the right solution set up.
Fantastic, thank you. So if they wanted to do water level but have the remote monitoring, what would you suggest in that case?
So water level with remote monitoring, the RX 2100 is I forget exactly what the option is, but the RX 2100 family is the lowest cost solution. If you're combining water level with a wireless sensors, so you want to be able to get other data at a specific at other points, then you would need the RX 3000.
Great, thank you. We had another question on the wireless, the RX 2100 and 3000 for remote monitoring. How many wireless sensors can you connect to these stations? And also, how far apart can they be set?
So in terms of maximum number of sensors, it depends on the sensors you're combining. So the rough number is 50 wireless sensors and up to 5 wired on the RX 2100, up to 10 wired on the RX 3000. For most sensors that only take up 2 or 3 data channels, you can get up to 50 wireless sensors. However, we've recently launched the multi-depth soil moisture sensors and that measure soil moisture and temperature at various depths. These consume many more data channels, and so we also have a specification of 336 data channels max. So that equates to, I think, the longest probe. I think you can connect up to 18 of these devices. So it really depends on the sensors. In most cases, you can use the estimate of 50 tops.
Great, thanks, Richard. There is another question here from Eric, and I believe what he's getting at is the durability of the stations and whether they can be deployed in areas that are prone to flooding.
Yeah, so these devices are they are designed to be exposed to bad conditions. They are designed for, I mean, they're deployed for in very hot and humid to very cold locations. They're subject to ocean spray all the time. They're not designed for submersion. So if the concern is that they'll be underwater for an extended period of time, I don't believe that is that the IP rating meets that requirement. But in terms of being exposed to rain and water splashing, they'll be okay.
Great, thanks, Richard. Okay, I think we're at a good time now, so I think if anybody else had any questions, we can certainly follow up with them afterwards. And I just wanted to remind everyone that we do have a survey at the end. If they have any questions, if they could please tick yes to being contacted by a sales application specialist.
Great, thank you, Jessica, and thank you, everyone. I do have contact info for a lot of our global sales folks there, or just feel free to reply to any email you get from Jessica in the next couple of days, and I'll be sure to get those emails from her and reply with any additional questions you may have. So thank you all, and have a great day.